हेलो फ्रेंड्स, वेलकम टू माय स्टडी पॉइंट। इस वीडियो में हम एप्लीकेशन ऑफ बर्नौलीज थ्योरम एंड विस्कोसिटी एंड रेनॉल्ड नंबर के बारे में डिस्कस करेंगे। यह हमारा फ्लूइड मैकेनिक्स का 6 वीडियो है। पुराने वीडियो को देखने के लिए डिस्कशन बॉक्स को चेक करें। यदि यदि आपको वीडियो अच्छी लगे तो लाइक करें एंड शेयर करें, सब्सक्राइब करें। So let's we start the first application of Bernoulli's theorem. So first is the benchrometer, and it is the device which is measure the rate of flow of discharge of a pipe, and it is based on the Bernoulli's application. And Bernoulli's theorem is based on the conservation of energy. So benchrometer is also work on the conservation of energy. We will calculate the discharge through the benchrometer. So Q is equal to the A1 A2 into root के अंदर 2GH upon under of A1 square minus AT square. So A1 A2 is the one end area of at one end, and the area of A2 is the another end, and H is the height of benchrometer, and so A1 A2 is the cross sectional area of pipe pipe endage. So next is the orifice. Orifice, it is also discharge measurement device, and which is measure the discharge of a pipe, and it is also based on the Bernoulli's application, yeah, Bernoulli's theorem. So calculation of orifice, the calculation of discharge through the orifice Q is equal to the A1 A2 के अंदर 2GH upon A1 square minus T square under. So it's the same discharge through the orifice and benchrometer. So next is the application is Python tube, and it is measure the velocity of moving fluid, yeah, moving liquid, and it is also based on the conservation of energy, and it is application of Bernoulli's theorem. So V is equal, the velocity is equal the root के अंदर 2gh. H is the height and g is the gravitational acceleration. So this equation is derived from the Bernoulli equation, where is the pressure energy is equal 0 and potential energy is at one end, another, and the potential energy at another end is equal, and it is this equation is derived from the kinetic head and the potential head. So इस वीडियो में मैं इसका डेरिवेशन नहीं कर रहा हूँ, क्योंकि यह मेरा शॉर्ट वीडियो है, शॉर्ट रिवीजन वीडियो। नेक्स्ट, Darcy's formula. Darcy's formula, Darcy's formula, it is head loss due to the friction head along the length of a pipe to the average velocity of flow of a fluid. So HF is equal to the head of discharge due to the friction, head loss due to the friction is equal to the 4FLV square upon 2GD. D is the diameter of pipe, G is the gravitational acceleration, and F is the frictional factor, coefficient of frictional factor. L is the length of pipe, V is the velocity of pipe, and Re is the Reynolds number. So let's we discuss the what is the Reynolds number. So it is the ratio of inertia force to the viscous force, and it has no dimension. It is a dimensionless quantity. So Reynolds number is equal rho Vd upon mu. Mu is the dynamic viscosity. So for this, some important conditions of the flow as laminar flow, the Reynolds number is less than 2000, and next, for the turbulent flow greater than 4000, and for the transition flow, so greater than 2000 and less than 4000. So next डायनेमिक एंड काइनेमेटिक विस्कोसिटी के बारे में। फर्स्ट इज द डायनेमिक विस्कोसिटी एंड काइनेमेटिक विस्कोसिटी। डायनेमिक विस्कोसिटी according to the Newton's law, Newtonian fluid is shear force tau is equal to dynamic viscosity into the velocity gradient, like this. So we will calculate the dynamic viscosity from this equation. Shear force, it is a product of a shear force and velocity gradient. Then here the unit of dynamic viscosity is Newton second per meter square in SI unit, and dynamic dyne second per centimeter square in CGS. So one dyne per one dyne second per centimeter square is equal to the 1 poise. So this is one standard one one standard equation, yeah, one standard equality is 10 poise is equal to the 1 Newton second per meter square. And ये रिलेशन कई बार एग्जाम में पूछा गया है, जेई लेवल पे, एसएससी में कई बार पूछा गया है। इस बेसिस पे बहुत सारे न्यूमेरिकल भी सॉल्व किए जाते हैं। दिस इज वेरी इंपॉर्टेंट। नेक्स्ट इज द काइनेमेटिक विस्कोसिटी एंड इट इज द रेशियो ऑफ डायनामिक विस्कोसिटी टू द डेंसिटी ऑफ फ्लूइड. So kinematic viscosity is equal to the dynamic viscosity to the density. So here is the mu is the dynamic viscosity and the rho is the density of fluid. So in meter square per second in SI unit, and centimeter square per second is the in CGS unit. So one stroke is equal to the 10 to the power minus 4. So 1 meter square per second is equal 10 to the power 4 stroke. Stroke is the CGS unit. यहाँ पे हमारा वीडियो खत्म होता है। थैंक यू वॉचिंग माई वीडियो। दोस्तों, वीडियो बनाने में बहुत मेहनत लगती है। अगर वीडियो अच्छी लगी हो तो लाइक करें एंड शेयर करें, सब्सक्राइब करें। थैंक यू वॉचिंग माई वीडियो।